On RT1-6, we're going to learn the distance formula, and we're also going to learn the formula for a circle, or equation rather. So we can use the Pythagorean theorem to find distance on a graph. So if I want the length of that purple line, I can use the Pythagorean formula using that red distance and that blue distance to calculate that purple distance. So this red distance will be the change in x. Or I can think of it as subtract one x value from the other, so x2 minus x1. That blue distance will be the change in y. Or I can think of it as subtract one y value from the other. If I think about my Pythagorean formula then, c squared equals a squared plus b squared. In this case, c squared is really the distance I'm looking for. So my distance squared will equal each side squared and added together. Since my sides are the change in x and the change in y, I can do the change in x squared plus the change in y squared will equal distance squared. But if I want a nice easy formula, I can say, hey, the change in x is just x2 minus x1, and the change in y is just y2 minus y1. Sometimes kids get really worried, they don't know which value do I use for x1, which one do I use for x2. It doesn't matter as long as you're consistent. Okay. And very often we see that, hey, we want just the distance by itself. So I can take that entire equation that I had before, and I'm just going to throw a square root sign over the whole thing on this side. So then I have my distance by itself. So my distance formula ends up being the square root of x2 minus x1 squared plus y2 minus y1 squared. And it's really important that I remember my order of operations and that I'm subtracting first, then squaring, then adding and taking the square root. There's also a handy little song to the tune of Thrift Shop. Really the important bit is this part. If you get this stuck in your head and you know it for any of those big tests, whether it be the test for this course, for the ACT, for the SAT, whatever, you'll have it just fine. And if I read through that or I hum through it in my brain, I can say, all right, I'll subtract x and y's. So I'm subtracting my x's, subtracting my y's, square, add them up, and then just take the square root. So we'll practice this a little bit. As I'm thinking through that formula, I know my distance says, hey, subtract your x and y's, square, add them up, take the square root. And now I'm going to fill in all of my numbers. So I filled in my numbers. Now I'm going to go ahead and subtract. So I get that the difference of my x's is -1. The difference of my y's is -18. My next step is to square each of those. -1 squared is +1. -18 squared is +324. When I add those, I get that my distance is the square root of 325. And now in this course, we haven't actually reviewed how to simplify radicals. So you could leave your distance as this. You could also round to the nearest hundredth and say, okay, this is going to be 18.03, about. If you remember how to simplify radicals, and you want to say, hey, this is the square root of 25 times 13, which is square root 25 times square root 13, and you want to write it as 5 square roots of 13, this is technically the most correct answer, but that is something that we will learn in RT2-2. On this next example, we have our 3 vertices, and we're asked, hey, does that triangle scalene, isosceles, or equilateral? So I'm going to find the distance between all 3 sides. So I'm going to have xy, xz, and yz. And then if I compare the distances, I can tell what type of triangle I've got. So I'm going to start with my formula. I'm subtracting my x's, subtracting my y's, squaring each, adding them up, and then taking the square root. For xy, I'm using 2, 2, and 13, negative 4. So I'm looking at my x values first, from 2 to 13. I'm going down 11. Then I'm going to look at my y values from negative 2 to negative 4. I'm going up 2. Negative 11 squared will be 121. 2 squared is 4. So this distance equals the square root of 125. I can leave it like that if I remember how to simplify fractions, or radicals rather, and I want to write this as square root of 25 times square root of 5, 5 square root of 5. I can certainly do that. That is something you'll learn next unit though. I'm going to do the exact same thing now for xz. So I'm still using x, but this time I'm going to use z as my second point. Same exact formula. So I'm starting with my formula, and I'm looking at my x values from 2 to 8. I'm going down 6. And I didn't quite give myself enough room. Do the same thing with my y's. From negative 2 to 6. My change is negative 8. And now I'm squaring and adding them up. So I get 36 plus 64. That's the square root of 100. So this distance will be 10. I'm going to do the exact same thing with yz. But already just looking at this distance and this distance, I know it's certainly not equilateral. So I can cross that one out. I'm starting with the same formula, but this time I'm looking at point y and point z. So my x values are 13 to 8. My y values, I'm going from negative 4 to 6. I need to square both, add them, and take the square root. 13 minus 8 is 5 squared. Negative 4 minus 6 is negative 10, and I need to square that. So I'll get 25 plus 100, or the square root of 125, which is what we got up here. So because I have two distances the same, I know this triangle is isosceles. We can also use this to find the equation of a circle. So when I'm thinking about the distance formula and the Pythagorean formula, we said the distance squared was x2 minus x1 squared plus y2 minus y1 squared. And we often write it as d equals and take the square root of everything. If I think about the equation of a circle, my hypotenuse is the radius. If I were to make a right triangle between the center and a point on there. So I can put r in for what the distance or the hypotenuse was. Then the distance between the edge of the circle and the center will be the difference between the center and any point on the circle x. So if I subtract x and h and then square it, I get what would have been x2 minus x1. And I can do the exact same thing with my center y value and any y value on the circle. And now I've got an equation for a circle. So the equation of a circle will be the radius squared equals x minus h squared plus y minus k squared, where your center is at the point HK. Here's a handy song to the tune of Call Me Maybe. Again, if you get this stuck in your head, it's going to be way easier to remember this when it comes to those big scary tests. Again, this is really the only part that's important. So if I'm able to hum along with this or read it or remember the beat, I can do r squared will equal x minus h squared plus y minus k squared. I know it, hooray. So I'm asked to write the equation of a circle. I'm given my center and I'm given the radius. I'm going to start with my formula. R squared will equal x minus h squared plus y minus k squared. My radius is 7, so I put that in for r. I'm leaving x and y completely alone. The only numbers I fill in are r, h, and k. So I'm looking at my center. My center x value is 2. That goes in for h. My center y value is -4. That goes in for k. And I'm done. Oftentimes we'll rewrite it and we'll do 49 equals all of this. But technically 7 squared works as well. This time we're asked to identify it. My center will just be the square root of whatever's over here. So I get 6, or not my center, my radius. Sorry. My center then will be the negative of the number that's with the x and the negative of the number that's with the y. So a -2 and a -5, positive.